Hi learners, welcome to the today's topic. Our today's topic is rule-based classifier basics. So what are the basics are there? What are the important terminology are there? We will cover. Myself Priyanka Gupta. I am working as assistant professor in Department of Computer Science and Engineering Data Science at Institute of Aeronautical Engineering, Hyderabad. I'll cover the today topics are I'll cover the what are the different characteristics of rule-based classifier. What is rule-based classification scheme? What are the different building rules through the direct method? How directly we can made the rule for that rule-based classifier. In that we will cover sequential covering method and rule growing method, and then we will cover the instance elimination. Let's start. Characteristics of rule-based classifier. So if we want to convert the result of any decision tree, we have covered the decision tree in earlier classes. So if we want to convert the result to of the decision tree into the classification rules, which we have some of the rules we have written. So these of the rule would be mutually exclusive as well as mutually exhaustive at the same time. So only one rule can be have the mutually exclusive nature, and that can also be exhaustive in nature. So what is mutually exclusive rules? So the classifiers, the rule-based classifier, those are going to contain the mutually exclusive rules. So if what are the conditions are there? If the rules are independent to each other, for every record that is covered the only one of the rule. So that is going to cover only one rule for that each record, for each tuple. So that will be the mutually exclusive rule. What is mutually exhaustive rule? The classifiers has exhaustive coverage if it accounts for every possible combination. So how many combinations can be there for one rule? That would be the exhaustive nature. So the possible combination of any attribute value will be accounting for the exhaustive nature. That will be mutually exhaustive. And for each of the record, that will covering the at least one of the rule. So in the mutually exhaustive, that is at most going to cover the one rule. But in the mutually exhaustive, that is going to cover the at least one rule. So one rule should be there, more than one rule also be accepted. So that was the mutually exclusive and exhaustive properties. So these of the two rules can be simplified also. However, we can say the simplified rules may no longer be mutually exclusive since a record may trigger more than one rule. So if more than one rule it is going to cover, more than one rule it is going to be covering, be triggering, so that will not be the mutually exclusive. So that is the one property of this exclusive nature. Some of the simplified rules, we can say that cannot be mutually exhaustive. We have covered the exclusive, but what are exhaustive? When they will not be exhaustive? When either since a record may not be going to trigger at least one rule, at least any of the one rule, so then it will not be mutually exhaustive in nature. So that for the rule-based classifier, those of the rules will not be anymore mutually exhaustive. So what are the solution we can take for that? If two of the one of the rules or more than one of the rules cannot be mutually exclusive as well as exhaustive. So some of the rules are there when mutually exclusive is not there anymore. So what we will do? Two of the set are there. We have to do the ordered rule set. We have to set the rules as a ordered set. Another thing is an unordered rule set. So in that we are going to use the voting scheme. So for that, for any of the branches, or we can say any of the node, we are going to do the voting. Whatever high voting we there, we are going to choose that branch. We have to go with that branch. We have to extend that branch. So like this, we have to set the rules for decision tree. If there is no exhaustive rules are there, then what we will do, the solution is there. The solution is we have to use a default class. So we have to make it the default rule for that, because whatever is there, we have to keep it as it is. So that will be the default class for that. So those are the two solutions for that, when no longer will be the mutually exhaustive and exclusive property will be there in one rule. Now, what is ordered rule set? The ordered rule set is nothing. The ordered rule set is known as a decision list also. That is nothing but the decision list where all the rules will be kept in a one list in ordered way. So that rule will be rank ordered because that is ordered in nature. So that will be, the ranking will be there for ordering. It can be decreasing and increasing, but order should be there according to their property. So that will be ordered according to, based on their property of the rule, right? So for example, when a test record is there, when a test record will be there to the classifier, it is going to assign to the class level to the highest ranked rule that is going to be covered, that is going to be triggered. So whatever the highest priority rule is there, we have to from the classifier, it has been keeping as a highest ranking. So if none of the rule will be fired, none of the rule are gonna be fired, so it is assigned to as a default class. So for the when it is the rule will be not exhaustive, we are going to use the default class. So when the any of the rule is going to be fired, then only the default class will be happen. So that is, if any one rule if more than one rule is going to be triggered, more than one rule will be there for mutually exhaustive, then we are going to use the conflict resolution. So for that, what is conflict resolution? Conflict resolution is of two types, that conflicts should be there and we have to resolve that. So some of types of resolutions are there: size ordering, class-based ordering, and rule-based ordering. So rule-based ordering is nothing but the decision list. But what is size ordering? It is going to assign the highest priority to the triggering rules. So what are the rules are going to be covered by that particular tuple, the particular record. So that is going to be the highest priority. So that is having the toughest requirement. So what is toughness? Toughness is nothing but the highest priority of that particular rule for that tuple. So the toughest requirement we will cover for that, and that will be the most occurring attribute test. Whatever the attribute is there, how frequently it is going to be occur. So that will be the toughness of that particular attribute. So according to that, we are going to make the highest priority of the rule, right? So what is class-based ordering? It is going to be decreasing the order of prevalence. Prevalence is nothing but the frequency of what is the frequency of the occurring of the same attribute. So in that class-based ordering, we are going to do the decreasing order. We are going to see the decreasing order frequency. What are the misclassification is there for per class. So in size-based or class-based ordering, that is going to be happen. For rule-based ordering, that is also the decision tree. The rules are organized into one long priority list. So the one priority list will be there, that is the decision tree, and all the rules will be kept there. And according to some measure of the rule quality by the expert, as well as some of the measures were there, accuracy and toughness, according to that coverage, according to that we are going to keep it in order in the rule-based ordering. So from that decision tree in the highest priority, that will be on the basis of that measures, what are the accuracy is there, what is the coverage are there, on the basis of those, and as well as by the domain expert, what is there in the highest priority, we will the classifier is going to classify that particular rules as according to the highest priority of the particular measures. Now, the rule-based classification scheme. So now we are going to talk about a rule-based classification scheme. That is nothing but that is also called as a decision list. But rule-based classification scheme consists only of the following component. That is going to have the rule induction algorithm, rule ranking measure, right? So what is rule induction algorithm? This is going to refer to the process of extracting the if and then rules. So what is the relevant if then rules are there from the data, which can be done directly using the sequential covering algorithm. So in the rule based classification scheme, the sequential ordering will be covered. So if then rules will be there from the data, that is the rules are covering the sequential covering algorithm as well indirectly from the other data mining methods like decision tree building or association rule mining. So those will be the rule and induction algorithm. So these are the rules are nothing, these are the algorithm are nothing but the rule induction algorithm are there. What is rule ranking measure? So this refers the same value that are used to measure the usefulness of one of the particular rule that is providing the accuracy prediction. So how accurate the rule is going to be, cover the tuple. So that will be the rule ranking measure for that. So the rule ranking measure are going to be used in the rule induction algorithm to remove the unnecessary rules, and that is going to improve the accuracy and efficiency also. So that was the property of rule ranking measure. The other properties they are also used in the class prediction algorithm, that is going to give the ranking. So the ranking of the rules they are going to give, and which will be the utilized to predict about the class of new class. So predict the class of new class. For that, the class prediction algorithm will be used in the rule ranking algorithm. Third is class prediction algorithm. So the given a new record with unknown class. So if we don't know a class, that will be the unknown class. For that, the class prediction algorithm is going to predict about the class of new record. So what are the new records we are going to add? For that, it is going to classify. So based on the if then rules that are the output for the rule induction algorithm. So some of the property are there. In many cases where multiple rules will be there, that could be matched by the new case. So the new tuple that can be matched by the already written rules. But the rules ranking measure will be used to either select the best matching rule. So in that also, the best matching rule will be preferred. The rule based on the ranking, we can say to compute any aggregation, any of the we can say merging of the rules from the multiple matching rules. We are going to order how to predict about that. We are going to predict about in order to arrive. What is going to arrive in the order in the rule based matching? We are going to compute that and aggregate that. Earlier, some of the rule-based classification methods were there. That was FOIL, FOIL, AQ, and CN2. But now we are usually going to use the Ripper. That is Ripper. So those were the other algorithm were there. So these are the methods that is inducing the rules using the sequential covering algorithm. So in that, where rules will be learned only one at a time. So the rules can be going to learn about only at a time. So the sequential covering algorithm that is going to extract the rule directly from the training data. So what is actually sequential covering data? That is nothing but what are the rules? That is nothing but that is going to extract the rule from the training data, that is directly. So that is nothing but the sequential covering rules, algorithms. Now, the decision tree classification methods are there, that like C4.5 that can also be considered as a form of rule-based classification. because however decision tree induction involving the parallel rule induction. So parallelly where rule will be introduced at the same time. So for that, decision tree classification methods like C4.5 also be considered as a rule based classification. Now, even more recently, we are using advances in association rule mining that has made it possible to mine the association rules efficiently in the order to build a classifier. Such an approach can also be considered as a rule-based classification. So those of the rules what are covering the association rules for the data mining, that will be also be the rule-based classifiers. We can also consider them. In it, some of the rules are learned sequentially, each for the given class. If class is CI, that is going to cover many tuples like of CI, but none of the tuples for the other classes. So for the same class only, that is going to cover the different tuples, but not for the other classes. That the rules will be sequential for the rule-based classification. Now, we are going to build the rules through a direct method. So what are the direct methods are there? How we are going to use write the rules for that? So direct method, extracting the rules directly from the training data, from the data. What is available there? That is nothing but the training data. What we know. The sequential covering algorithm, that is also the direct method. So that is having the CN2 algorithm and repair algorithm. So for that, they are common to direct methods for building the classification rules. So for that, for example, if you are using the Ripper method as an example, so for the two class problem, the two class problem is there. Choose one of the class as positive class and one of the class as negative class, and then learn rules for the positive class, and negative class will be the default class. So in the Ripper method, we are going to use the two class problem, and then two class problem we are classify the two classes as a positive and negative, and the positive class will be referred as a to learn the rules from that. That will be the learning data. That will be the training data, and the negative class will be the default class for that. As well as if we are taking the multi-class problem, for that the classifier is going to order the classes according to the increasing class frequency prevalence. So fraction of instances example that belongs to the particular class, and that is going the classifier is going to learn the rules set for the smallest class first, and after that treat the rest of the negative class. So rest of the classes will be treated as a negative class, and that will be repeated, that will be iterative in nature. Till then, next smallest class will be the positive class. So for the multi-class, the same order we are going to do. For if the classifier is going to do the same of the rules. What is sequential coverage? That is nothing but the direct method. What are the steps we are going to do in that? The classifier is going to do. So there are few steps to apply the sequential covering algorithm. The first step is start from a empty rule. So that will be starting from empty rule, the classifier. The second step will be the classifier have to grow a rule using the learn one rule function. That is the rule growing function. On the basis of that, the classifier is going to write the learn one rule. After that, in third step, that is going to remove the training records. What are the training records are there covered by the rule? So that what are the records has been covered, what is the tuples have been covered from that particular rule, that will be removed from that. So that will be the instance elimination for that particular record, that particular rule. In the fourth step, we are going to repeat the second and third until the stopping criteria is going to met. So the classifier is going to do the second and third step again and again. And in the fifth step, we are going to rule the pruning. So what are the rules are not required, we are going to remove or prune that. So that will be the last step of that particular sequential covering algorithm. So that was all about the sequential covering algorithm. Now, rule growing. So that is the direct method of the rule-based classification. So for that, general to specific strategy is there for Ripper algorithm. So that will be the start from an empty rule, that will be assigning as an empty rule to the class, and then that will be added in the next step, that will be added conjuncts that maximizing the files information gain measure. So there in the particular Ripper algorithm, the classifier is going to classify they're going to compute the gain of the files. So in that, the gain of RO, if suppose R0 and R1 is the rule, two of the rules are there, so gain of both will be the T of log log P1 P1 plus N1 log P0 plus N0, and into gain of R0 and R1. So that will be equal to T of log P1 into P1 plus N1 minus log P0 plus N0. So that will be the information gain for the files measure. So that will be the second step. In third step, the R0 that is going to point the that is empty class. So that will be the initial rule for that. Again, the R1 that is classify the A class, that is going to add the conjunct in that. So that will be the fourth step for that. Now the general to now the what are the terms we have used there? The TT were nothing but that were the number of positive instances covered by the both R0 and R1 rule. The P0 that was nothing but the number of positive instances covered by R0. What was N0? That was the number of negative class classified covered by the R0. P1 was nothing but the number of positive instances covered by the R1, and the N1 was nothing but the number of negative classes instances for the R1. So that was the important terminology in that particular algorithm. So now for the CN2 algorithm, what will be the steps there in that algorithm? The first step will be there. We have to start from an empty conjunct, that is the empty class, right? Now in the second step, we have to add conjunct that minimizing the entropy measure. In that we have to add measures like A, B, right? Comma will be there. So like we have to add some of the conjuncts in that. In the third step, the classifier is going to do that is going to determine the rule consequent. The rule consequent is nothing but the left hand side rules, whatever will be there. So that is going to taking the priority class of instance that is covering the same rule. So these are the three steps will be there for CN2 algorithm. Now instance elimination. So what is instance elimination? Why do we need to instance elimination? Instance elimination is nothing. We have to eliminate some of the rules from the particular rules. We have to remove the some of the attribute rules. So why we do that? So otherwise we have to do the next rule that will be identical to previous rule. Why do we remove the positive instances? We have to ensure that the next rule is different, then only we are going to remove the positive instances. Why do we remove the negative instances? We have to prevent the understanding. We have to understand about the accuracy of rule. To prevent that, we are going to remove the negative instances. What is rule evaluation? Rule evaluation, assume if Nn is a number of instances, Nn is number of instances that is covering the rule, that is the tuple is having all the attributes in the same rule. NC is the number of instances covered by rule, and KK is nothing but the number of classes, and PP is probability. Then the accuracy will be there. The accuracy will be NC divided by NN. So that will be accuracy of the instance. So that will be the rule evaluation measure. Laplace will be there. Laplace will be the nc plus 1 divided by n plus k. So that will be the Laplace measure for that. M estimate measure will be the nc plus kp divided by n plus k. So these are the three measures are there to do the rule elimination, rule evaluation. Now the stopping criteria is there, that is going to compute the gain. So information gain basically. So the gain is not significant. The classifier is going to remove that particular, that is going to discard that particular new rule. That will not be taken. That will not be carried forward. Now in the rule pruning, the rule pruning will be the similar to post pruning of the decision tree. So post pruning is nothing but after the completion of that decision tree, what are the unnecessary rules are there, what are the unnecessary attributes are there, we can say what are the similar attributes are there. If there is some match is there, some relevance is there, so the from the classifier that particular rules will be removed from the that decision tree. Reduced error pruning, that is how to remove the error pruning basically. So we have to remove one of the conjuncts in the rule. So try to remove one of the conjuncts that is added with the some of the particular and or measures and or so that we have to remove from that particular rule. So that will be the error pruning for that. We have to compare the error rate on the validation set before and after the removing that particular rule. And then if the error will be improving for that particular rule, we have to prune the conjuncts also. After that also, we after the improving the error, we also have to remove the different conjuncts and from the attributes from that particular rules. So today we have covered the what are the rule ranking algorithm are there, class prediction algorithm are there, and different rule ranking algorithm are there. We have also covered the CN2 algorithm and Ripper algorithm. In that we have to do the direct elimination. We are going to write the classifier is going to write the direct rule from the different tuples. So the tuples are nothing but that are the record are there. On the basis of that record, if some of the association rules we are going to write, that will be the condition will be there. That particular rule have to cover all of the tuples and records from that particular database. So if that will be the direct method is there, we have to write the direct rule for that. So that in that we have covered the class prediction, rule ranking, and rule based classification. For that, what are the Ripper algorithm are there? In that we have to in CN2 and CS Ripper algorithm, the classifier is going to use the elimination of the particular rules if that is not needed for that particular record. So in the post after the decision tree we have made, after that post pruning will be there. So after the post pruning, when it will be completed, the error will be recorded. What is the error is there? If error is also removed, then we again we have to eliminate the what are the conjuncts, what are the extra attributes rules are there written. So in those particular algorithm that is having the direct method, in that particularly we are going to minimize the rule. So that condition will be there, that is covering the all of the particular tuples, whatever is there in that particular database. So that was all about the different rule-based classifier basics. What are different important terminologies are there related to the rule-based classifier we have covered today. So that was all about today's class. Thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.